Quick in Algebra 2 today, what we covered was how to solve a logarithmic equation. And so just very similar to what the other day when we had an exponential equation. We had something that had an exponent like this. Okay? When we had a common base, we could just simply take the exponents and set them equal to each other and solve the equation when we had that common base. That's what we did with exponential equations. Okay, well, when it comes to a log equation, when we have a common log base, so we have log base 3 on both sides, we can take this portion, this x, and set it equal to 8. X has got to be equal to 8. And there's nothing to solve there because x is already by itself. Over on example B, we've got a common log. We've got both log base 5 on both sides. Well, if they have the same log base, that means this part of the equation, x squared minus 44, has to equal 7x. Okay, you got to go kind of think back to your Algebra 1 days, and we've done this a few times this year. How do we solve a quadratic? It's got something that's to the second power. We want to move our terms to the same side. So we're going to get x squared minus 7x minus 44 equals 0. How do we solve a quadratic? Well, one way we can solve it is we can factor it. Okay, this happens to be factorable. It's going to factor into x minus 11 and x plus 4. If your quadratic ends up not being factorable, we can always use the quadratic formula. Okay, I'm going to set these equal to 0. Okay, anytime I have two things, if I multiply these two values together and I get 0, that means one of them has to be equal to 0. So here I'd add 11 to both sides. Here I'd subtract 4. So I have two possible answers. I have positive 11 and I have negative 4. When you get two answers like this, you definitely want to go back and plug them in to see that both of them work or to see if one might be extraneous. If I plug 11 into here, 11 squared minus 44, is that equal to 7 times 11? No, 7 times 11 is 77. This would be 121 minus 44, and that also equals 77. So 11 works. Okay, that is definitely a solution. Okay, when I plug in the negative 4 here, I get 7 times negative 4. That's a negative 28. And I can actually stop right there. We talked about this when we introduced logs, is that we can't have a negative value here. There is nothing. 5 to what power would equal a negative 28? Well, there's no exponent I could plug in where I would get something that's negative. So this does not work. That is considered an extraneous solution. So you would cross that out. The solution is x equals 11. Same rule applies when it's a natural log. Both sides are natural logs, so we're just going to set x squared minus 16 equal to 6x. Okay, because it's a quadratic, everything has to be on the same side. And have it set equal to 0. We're going to attempt to factor it. This one also is factorable. I'm going to factor in x minus 8 and x plus 2. So my two solutions, I would say x minus 8 equals 0, or x plus 2 equals 0. So we get x equals 8, or x equals negative 2. When I go back and I plug those in, same kind of thing happens. If I plug the 8 in here, I get 64 minus 16, which is 48. When I plug the 8 in over here, I get 6 times 8, which is 48. So those are the same. That's a solution. And when I put the negative 2 in, negative 2 squared is a positive 4, but minus 16, that would give me a negative 12. Okay, we can't take the natural log of a negative number, so that is an extraneous solution. My only solution is x equals 8. Now, it's possible that when you get two solutions, they might both work, so you'd have two solutions to that equation. You could plug them in and maybe none of them work, and then you have a no solution. So don't assume that if you get two answers, one is always going to be extraneous. It's just the way that worked out.